Yeah,
Okay, yeah.
sure. See, at the end of the day, we want to run an application, right? The applications will be running in the worker node. The worker node's main intention is to actually support running container environment, right? So we have already containerized the applications. We want to run those applications. We will be running it in the worker node. But what's the actual role of Kubernetes? Kubernetes is a container orchestration platform, right? So see, even nowadays, all the AML workloads, they are being set up in Kubernetes because of its robust support for reliability, fault tolerance, all these things. Kubernetes is very optimal for running AML workloads. We want to run this. We really need lot of CPU power, for AML workloads. So also, uh, nowadays there is a lot of consolidation happening. So a single website is holding a lot of lakhs of users. You really see, slowly the world changed towards consolidation, right? So Google, Amazon, Microsoft, they are controlling many things to a large extent. So at the same time, multiple users are logging into a system and accessing the services. So we want a robust system to deploy such applications where multiple users can log in and make use of the services. Okay, so the main components of the master node are etcd, API server, controller manager, scheduler. See, actually, I mean, don't think like these arrows are very important, but at the same time, the interactions are even complex than this, right? So these components interact with each other, but it's not just in this way. Like they kind of give acknowledgement to every message. They all communicate with each other. Is okay. So that you need to remember. So HCD is for a data store. API server is the main component from which the kubectl, the Kubernetes client will be accessing all the requests from the users hit the API server. And then we have the controller manager, which is actually going to control the resources. It is going to take care of the nodes. It is going to take care of the pods. Pods we will see later. Scheduler is going to decide which pod needs to run which node. So the decision will be made by scheduler. Okay. Kubelet is an agent running in the worker node, which is actually going to communicate with the API server regarding have I started my pod, such kind of stuff. Docker container runtime is the main engine, right? So we have already done this, right? So we first start the Docker daemon and then we start running the Docker container. So the same Docker daemon is what is about Docker container. And then we have the image store. This is where we have containerized the application and pushed the images. We'll be pulling it from here. As I said, there are public repo as well as private repo. In case of large corporations, they will be making use of their own private repo, and they will actually make use of it. And people like us, like we want to make use of some existing Nginx image or a BusyBox image or a simple Ubuntu image, we'll actually make use of the public images. So that's it from the architecture point of view. So I have actually set up a cluster. I'll just show you that. Any questions here, Ganesh?
Got it, sir. Sorry, got it, sir.
Yeah, sure. See, what I did is actually I have created a Amazon Linux machine. Okay, so after that I will just show you what I did. Just to one second. So okay, so I just logged into the machine. There is only one requirement with respect to the Kubernetes. We need at least two CPU. Okay, if you go with a single CPU, it will fail, saying that I need at least two CPUs to run. It is resource intensive. And then I just installed the Git. Okay, so I'm just running this script. It is in the same data directory which we are making use of, right? So this you need to just git clone this minikube EC2 Git repo. After that, I'm actually running the Amazon Incube script. I'll just show you the script. Give me some time. So what this script is doing is it is actually installing the Docker runtime, and then it is actually installing some tools. So again, these are all some helpers which is required for setting up the Minikube. happens. So here is where I'm actually, just deleting if there is any existing instance, and then I'm actually starting the Unicube. I'm actually making use of the Kubernetes to download the Kubectl. Kubectl is the Kubernetes client, right? So I think this is something which we have seen earlier also, right? So we need to change the group for the EC2 user. These things are some, I'm just moving the Kubectl client to a local directory, and then, I want to do autocomplete. Just creating small alias to make it easy to invoke. So at the end of the day, I have set up the Kubernetes cluster. Okay. So the instead of running kubectl every time, I just put K. Okay. So this is a set of nodes. We have only a single node here. So any questions here? You understood what is node? Node is nothing but a server. Here we have only single node, which is control plane. So I'm just seeing labels. Labels are something like we can actually label. It's it's a literal meaning of the word label. You actually paste something, write something, and write on the label, right? Something like that. You actually tell that this node is for a specific purpose type of actually. So namespace.
So I
Namespace.
have a question.
Yeah.
I have a question. Sorry to disturb you. The script that you ran where you installed curl and everything. So is that
Yes.
like written by you? I mean, is it the user requirement to set up
Okay.
the Kubernetes cluster?
Yes, it is the administrator user's requirement. See, at the end of the day, the admin want to set up the Kubernetes cluster, right? He's going to maintain the cluster. He
Okay.
wants to, prepare the servers and all, for setting up the cluster. So he will do it. After that, the users, means the developers, can actually, start deploying it. So the maintenance will be taken care by the administrator.
Sure.
You can say, like in a small company, the administrator and the developer all are same. So, but it is actually a administrator's job to set up the cluster. You want to add something here, Shankar? Okay.
Yeah. Basically, it is part of the user data. You can actually put it inside the user data. That will take care of installation, configuration, and everything. So in terms of EC2 instance, I'm saying, but in terms of a real cluster, you may have to have a proper automation in place. That will be your infrastructure as code that is written in Terraform or maybe some other configuration tool, configuration management tool.
Yes. What? So see, I think you guys are very used to AWS, right? In in olden days, people used to set up the servers. They call it as bare metal, right? So they go and switch on the server using their hand actually. So they switch on the some 10 servers. Okay. So they need to prepare operating system in all the servers, and they have correct firewall rules. Everything prepared first, and then you actually run the script in one of the node, which is the master node. Okay. So the master node will be up and running. After that, you go to the worker node. You need to actually run a specific command to join the master node. Okay, from the worker node, you join the master node. So you go to the next worker node, you join the master node. So like this, if you do at the end of the cluster creation, if I run the same command like kubectl get nodes, you will see all the 10 nodes here. Then you get a configuration file which you make use of to access the entire cluster. When I say you access the entire cluster, you are actually going to interact mainly with the master node, which is actually in turn controlling and monitoring the entire cluster. Any questions here?
No questions.
Yeah. Shall I repeat it a little slow, because I think I might have gone a bit fast. Okay, so first you set up the master node. Okay, you run the script. Let's say you run a script. Okay, you prepare the Realm machine or you prepare the Ubuntu machine, whatever it is. You then run a script in the master node. So the master node is ready, right? Something similar to this, right? So, and then at the end of the installation, it will give a command. From every worker node, you need to run that command to join that master node. You do it in worker 1, worker 2, worker 3, all the worker nodes, okay? At the end of the day, if you come to the master node, or you can be anywhere else also, like you need not be in one of the master node or worker node, you can be anywhere else also. All you need is one configuration file. With the configuration file installed in your machine and Kubectl client installed in your machine, you can access the cluster, right? So in a big company like where there are hundreds of employees, you set up the cluster somewhere, okay, in some location, and then you actually share that configuration of the cluster to the user. The user get that configuration, he copy it to his system, and then he install the Kubectl client. He will access the cluster. He will start deploying the applications. Am I clear here?
Yes.
Okay. So maybe if you say, do it, you may understand it better. Okay. So this is how you get the node parts. And this is how you get the pods part. So pods, as I said, pod is nothing but a container, right? So pod is the basic unit in Kubernetes. It is a container. With the presentation, you'll see better. I'm just showing an example. And then you divide the projects by means of namespace. You create a namespace, and in that namespace, you start create the containers. See, one specific namespace can be like a front-end specific. Another namespace can be a backend specific. Another namespace can be something related to database, something related to storage. You create a namespace. Namespace is used for isolating the applications. Like all these type of application comes under this namespace. Like that, you segregate the applications. So just to give an example, you see, we have not installed anything. We just set up the cluster, right? So even now, there are 4 namespace present. Okay, default, kube node list. You don't have to really remember all these things. Just there are some 4 namespace created. Kube system is system specific. For maintaining the cluster, we need set of services to be up and running, right? So you actually have all the pods running inside the kube system namespace. Let's see what is there inside the kube system namespace. Okay, you have to do kubectl get all, and then the namespace you mentioned something like this. Are you able to see? So I'm telling, get all the resources in the namespace kube system. Okay, you see here, actually in the kube system namespace, we have different resources. There are set of pods running there, right? There is a service, there is a daemon set, there is a deployment, there is a replica set. So all these are different concepts. I mean, slowly, once you start using it, you will come to know. So as I said, there is etcd, there is API server controller manager. All these things are like the services which we have seen just now. Ganesh, you remember we have seen etcd, API server controller manager, right?
Yeah,
So you
yeah.
see, all the services are running as containers. How they are set up? Like when we set up the cluster itself, they are all set up, and they are all lying in the kube system namespace. Okay, so something similar to this. Let's see what is there inside kube public. Okay, there is no resource there. It is just to say that there is a namespace with public, publicly accessible. So there is something called node list. I am not aware what is there. So nothing is there. So in default also there won't be any resource. Okay, there is a service Kubernetes in here. Actually. So we'll see what is a service. So if you want to know what resource is lying in all the namespace, you say capital A, right? So you get something like this. So kubectl get all capital A in all namespace. What is there? So something like this you can actually check. Okay, so let's see. Let's see what's a pod, right? So
Why isn't the default listed there?
so basically it is like you want to run an application. By default it will be in default namespace. We don't want to run it in kube system, right? So if you run a simple application now, it will go in default only. So it is like your home, like a home space to run any application. Now, if you want to create a namespace, you say kubectl create namespace, something like see now I have created another namespace. DevOps. The default is something like you can say like a launchpad. There is nothing fancy here. Got it?
Yeah. Yeah.
You don't want to end up running anything in the cube system namespace, right? So they just created something for you to access. So I think we have seen the worker node components. Let's see what is a pod. Is the smallest and simplest unit in the Kubernetes, encapsulating one or more containers that share the same network namespace and storage. So a pod is nothing but the simplest unit in the Kubernetes. It has one or more containers. So usually a pod will have only one container. Most of the time I have seen one container. Sometimes you can have in a single pod, you can have multiple containers as well, right? So maybe they are so tied, it doesn't make sense to run one of them alone, right? So they are so tied up with each other and they help each other. Let's run both the pods, both the containers in a single pod. So that kind of scenario may arise. So where you actually have multiple containers in the same pod. But in general, I have seen most of the pods containing single container only. So they share the same network namespace and storage. Like we don't have to really do anything. All are sharing the network namespace. They all get scheduled together on the same node. So we can be very sure, like if we write a pod spec, right? So we can be very sure that it is going to run in a single same node only. So in general, it is temporary. They can be created and destroyed dynamically. So this is very true. Like in general, it is like a Docker container only, right? So by nature they are ephemeral. You just come and go. Like so, if you create some files inside there, it will go away and the restart because the data is not stored anywhere unless you go and do some configuration. It won't be stored. It is a basic building block for scaling and managing the workforce. When I say scaling, it means I want to scale up or I want to scale down. I want to increase the number of parts or I want to decrease the number of parts. I make use of that. So let's see.
Like, is there any scenario where two containers are tightly coupled?
See, actually, like for some reason, you want to look for there is application running, and the application is keep logging something. Okay, you want to do some logging, and you want to capture all the output to another file, right? So you can, so the application is running, it is just throwing into some file. You want to actually capture that file and store it somewhere else as well. So I'm just giving an example. So in one application, you keep logging. When I say logging, you keep appending some text. From another container, you want to transfer the same text to some other location. Okay, so to some other location, you want to see what is going on. So that kind of scenario, you definitely there is the logging cannot exist separately, and you want to ensure that both are coexisting. So that is one example. So depending upon the application scenario, so you can have multiple things actually. Like so,
Sure.
yeah. So see, it doesn't make sense to have a separate pod written for this specific purpose, right? So it doesn't make sense. Like unless I have application running, I don't have this logging, and it doesn't make sense to run it in a separate unit. It is again unnecessary maintenance burden, right? So that type of So there are some YAML files. So see, all the configuration is usually written in YAML or JSON files. So both are supported. We will see how to create a pod here, right? See, you just see the simple pod here. So this is the name. The name of the pod is Nginx container, and it is actually making use of the image name called Nginx latest. The container port is 80. Okay, so I'm just going to create the pod here. Let's see. So I create the pod something like this. Okay. So the container is getting created. The container, when I first ran, it is showing container creating, and if you really see, now it is running. So there are different ways to check the pods. Like I can say kubectl describe pod. The pod name is my pod, right? So let's see. So I'm going to just describe how the pod is. Okay, so it is actually giving me a lot of information. So the name is this. It is actually in the default namespace. See, one second. So in the namespace, you can actually clearly mention I want to run it in a different namespace as well. So this information you can actually specify when you create the pod. This pod namespace you want to run the application, you can specify. I just ran. Default is the default namespace, right? So it is running it in the default namespace. So the image is Nginx latest. Okay, and then it has actually assigned port 80 as we mentioned there, and these are like internal stuff. So it is actually pulling the image. After pulling the image, it is starting creating and then starting the image. So this is how we create the pod. Any questions here?
No, sir.
Okay, so let's go to the next part, deployments. See, by default, a pod is a simple single unit. It is about one container or multiple containers. You just define in a YAML file, right? So now we want to have a pod. We want to have some number of replicas. Like I want some 5 pods to be running. Okay, so I want at least 5 pods, 5 applications to be running at the same time. Why I want 5 applications? Because I have multiple nodes. Many users are visiting my website. So I want the application, the same application, to be served from different nodes. That way, I'm making use of the enough CPU, enough memory. So we have something called deployment. So in the deployment, you will mention how the pod is, how many number of replicas, and then additionally, it will be keep going. Like you can have service, you can have root, it will be keep going. Like usually the deployment file is quite big in nature. You can think like deployment is on top of the pod. I mean, once I show the example, you will understand it better. So this kind of deployments helps to create and delete easily. Like you create a deployment, it means what it will do, it will actually go and create some number of pods, a specific service, a specific route, a specific storage. So all the information will be there in the deployment file. You just go and create it. Now I want to delete the deployment, means it will go and delete all the resources one by one. I want to scale the replicas. I want to scale the number of pods. You just say I want to do kubectl scale. You can actually I'll show you the example. The number of pods you can increase, or the number of pods you can decrease. So all this is possible with the deployment. Deployment is the you can say you generally deploy applications using deployments. Just remember in that. Okay, so you don't actually maybe for some testing purpose you will make use of the pods, but at the end of the day, when you want to deploy a large application, you will make use of the deployments only. Let's deploy a deployment. what is this? This is the kind. This is very important actually. So in the YAML file, you will usually see the kind. The kind is of a deployment. What about pod? Let's see pod, right? So the kind is of the pod. What kind of resource is this? Is defined here. Okay. So go back to the deployment. Yeah. So here I want at least 3 replicas. As I said, I want to run 3 pods running at any time. Okay. And then this is label. So the label, as I said, like label is very important concept. Like, it is useful when you create multiple resources, right? By means of label, you can actually select. I want to see in my Kubernetes cluster matching a specific label, what and all resources created. So you'll be creating a pod, deployment service. You basically give same label to everything. That way, when you want to delete or when you want to scale, it is very easy because you can actually make use of the labels. Okay. So again, if you see here, I'm actually creating the container, same thing. If you see this is similar to the pod spec, right? So you are creating a container name, image name, and then the port. So this is what I said. A deployment is something on top of the pods. So a deployment contains a pod internally. Okay. So, but it can be something much bigger than pod. It can have multiple other resources required for Kubernetes. So let's create. See, you can actually do kubectl apply -f under the file name or create -f under the file name. So apply will actually, if there is any change you do, it will actually apply. Okay, create is for the initial creation. So I have created. Let's see what's that. See, actually, what it is doing. So this is something which we have created earlier. Now it is actually creating 3 pods, right? So it says my deployment, right? So the actual deployment is here. Okay, internally it has created 3 pods. Got it? The actual deployment is here. Internally, it is creating 3 pods. Why it is creating 3 pods? Because I have mentioned 3 replicas, right? Also, if you can see, this is another internal resource which is created by the deployment. It is called replica set. We want 3. Currently, we have 3. So decide is 3 and then the current is 3. So this is how it shows. Let's see whether it has created. Why it is taking some time? Because it needs to pull the image, it needs to update the LCD, all these things, right? So now if you see, it will be created. So we have created 3 pods. So all are up and running. Any questions here?
So is there any way for us to know which pod is created and which pod is placed in which worker node?
Yeah. So see, actually here we have only one node. So
So will that be taken care by the controller?
yes, that will be taken. See, all the components will be working together to do all these things, right? So as I already explained, we will be definitely making use of the HCD, controller manager, scheduler to make this working. Without that, the scheduler, without that, the Kubernetes cluster is not functioning.
Okay.
That is clear, right? So yeah. So actually, there is a way to get the. See, usually you get the help like this. Okay, kubectl get parts. I can actually show. Let me see. I have done this earlier. This one. See, list all the parts with more information, like the node name. Okay, you got it. So -o wide. If you use, you will come to know. Good. So actually, see, I'll just tell you about both the things. Okay. So here, what we are doing is we are trying to get all the pods. Show me all the labels assigned to the pod as well. Okay. So if you really see in the deployment file, I have clearly mentioned I want this label, right? You see here app equal to my app. It's highlighted. You got it? Hello?
Yeah, yeah.
Yeah. So, this is for show labels. Also here, I'm actually using wider format. Okay, so here you can see in which node it is running. Let's say we have some 10 nodes, right? You will know, right? All the 3 pods will be definitely running on 3 different nodes. See, actually it wants to do more reliable. If we run everything, just because systems are free, it will not run everything in a single node. It will try to spread out as much as possible so that even if one node goes down, we will be able to serve. This is for our own example, we are just using a single node, but in general, it will spread it out in those 10 nodes. The 3 pods will be running on 3 different nodes. Okay. Yeah. So, and then just to one thing needs to be clear, right? So the system, kube system, whatever parts are there in the kube system, they will be running only on the master node. They are all master components, right? So that you need to remember. In case of worker node, it will be running the kubelet and kube proxy and the Docker daemon. Yeah. Okay. So I just want to show you some more examples. Let me see. So, okay. So see, when you run the application, right? So I told you about describe already. I will just show you. Sometimes what happens is you may not have the YAML file of the existing resource. Someone else created, right? So some of your colleague might have created some other deployment. Now you want to get back the deployment file, YAML file. So you can actually make use of this one to get the YAML file. I'll just get pod, my pod. See, by means of this, I'm actually just trying to get that output of the YAML file. You see here, the same YAML file, I am actually getting it from the Kubernetes cluster. There are a lot of temporary system specific things it is actually adding. We don't want all that. We just want some basic things. When I say basic things, the API version, the kind, these are all the most important things. The image name, the image, that name given to the pod under the port. You're getting my point? See, we have seen the pod spec, right? It is something similar to this. But if I do a kubectl get pod in existing cluster, it is showing some additional information. All these are, given by the system, the Kubernetes system. Like you see, you just understand what exactly going on under the hood, right? So what and all it is trying to do, like you can just see, the simple pod itself. So something similar to this we can do for the deployment as well. Ganesh, Shatulya, are you following?
Yes, yes, I wanna.
Yeah. Or is it, if I need to slow down, let me know. See, something similar to that, we can actually get for the deployment as well. So someone else created the deployment, you want to get the YAML file of that, you just make use of this -o YAML. See here, same thing here, again, deployment. You have to come down. See, actually, what kind of strategy needs to be followed for rolling update? This is something very interesting. I mean, we'll see it later. Like how we want to do the update without disturbing the system, without disturbing any user who is getting served by this application. Like a lot of users are accessing the website, right? So, but we want to do some updates in the system as well. So such kind of things are possible here. This strategy is the default one. Whenever you create any deployment, it will actually go and put this, strategy. I have not mentioned any sort of this strategy in the deployment file. If you really notice. Got it, right? So in the container, in the deployment, we have this image name, and then I give an image. See, again, this image pull policy. This is very interesting, right? So if it is not present, you go and pull. Sometimes, if it is not present, you fail also, you can tell. Why we need that? Because don't go and access internet to pull the image. The image is already should be available. Don't go and pull somewhere from the internet. We want to follow some security. We can actually tell, don't pull, fail if the image is not present as well. So yeah, this is the status. This comes under status section. So many things are here, and then we have the replicas as well, right? So see, what is the number of replicas mentioned? How many of them are ready? See, it is not necessary that all of them are ready. For some reason, some might have failed. So in that way, you will see a lesser number here. But now we have a proper cluster. It is telling ready replicas as 3. So you can see the replica set as well, alone. The replica set is something which is created under the hood whenever you create a deployment. I just mentioned that I need 3 replicas, right? So apart from that, I have not mentioned about you go and create the replica set and all. So it is created automatically by the system. So, right. So let's see some other command. Any questions till now?
No.
So, okay. So see, we have these parts, right? We can actually see logs of the part using this. When I say logs, all the print statement which is coming from the application. Okay, so when the pod is created, what and all going on is given here actually. So what and all. So if you have some prints which is happening inside the application, it will come after that. But this one is not showing that. So you understand, right? So we are actually what exactly we are starting. We are starting the Nginx, right? So you can see Nginx related configuration here. Sometimes when you develop the application, you want to see what and all logs. Sometimes it crashes. The pod will crash for some reason. You will go and check here. Some other service you need to start first before starting the pod. So I'm not able to reach that. Such kind of information you will get from this log. This is useful for debugging purpose. So definitely, in the long run, if you are setting up the cluster, you will see some issues with the pod. You have to go and check the logs like this. So something similar to this, we can do a describe of the deployment as well. So, okay. So this is the deployment describe, like something similar to what we have seen. So, and then you will see some events here. So I think these things are very useful when you are debugging to see what is going around actually. Like, so you can actually see a deployment specific event here. In general, you can actually see events in general. Okay, you say kubectl get events, right? So what happened in my cluster, what application created, what pods created, all the events are getting logged in here. Again, this is useful in case of debugging what's going on in my system, what is the status now. Sometimes you may run out of memory, what is the reason, which image is causing that. So that kind of debugging time, you can actually make use of this. Are you able to see?
Yeah.
So you see, actually, like it is just to start. It is starting the kubelet. We are starting the container, right? So it is telling image name. So it is creating 3 pods here, right? One by one. Created pod, created pod. It is scaling up the replica set. The image name is getting pulled. So after pulling, it is creating the container, and then it is starting the container, right? So let's go to the next one. So something similar to the describe, we can do a logs of the deployment as well. You know, in general, a deployment will be even more complex. It will have pods, service, the root, different things actually. Like, let's do this, right? So we have the deployment with 3 replicas. Let us scale it. How many numbers you want? Finish. We'll make it 4.
Yes, Sharvana, but one doubt here is like normally 3 pods are running right here.
Normally 3
3
pod.
containers, yeah. In
Yeah,
pod, 3
yeah,
containers are running, right?
correct.
In only in one pod, 3 containers are running, right?
No. There are three pods running. In every pod, there is one container.
Okay.
Okay.
If
I'll just,
one container get down, like you already give 3 containers, sorry, 3 to be run, right?
yes, you see here. Yeah, I have put kubectl get pods. It is actually running three of them. You forget about this one, right? So I just scaled it. That's why it's showing additional one. For about the 13 minutes, past the 13 minutes, 3 of them are running. 1, 2, and then 3. All the 3 pods are created inside the deployment called my deployment. In each pod, there is a separate container. So 3 pods, each pod contains one single container. You are still any confusion?
So here
No, no,
we
no.
have mentioned only, we have updated the number of replicas and not added any, right?
Yes.
Replicas equal to 4 means that already 3 were there. So the
Yes.
remaining number will be added.
Added. Correct. So you can actually make anything here, whatever numbers you mentioned for this deployment. See, this deployment has 3. Now I'm telling, make the deployment have 4. Okay. Now I will tell, make the deployment have 1.
Yeah, Sharvana, sorry to interrupt. If any
Yeah.
one replica got down now, it automatically create or like what you said now.
Yes, it will create. I'll show you that one as well. So I'll just do this once. Now you see in this deployment, just make only single replica. Okay. So this is what happened. Now I will do what you asked for. I'm making it 2. Okay. There are 2 pods running because I want 2 replicas. I'm going to delete one of them. Okay. I'm going to delete one of the pod, which is the oldest one actually. Okay. I just deleted it, right? You see here, immediately it started. You can see the name actually to understand it better. See, I just deleted this 15-minute aged one, 4DFCD, right? So
Yeah.
it kept the other one as is. 3-second aged is now become 25. It created a new one, XW7S7, right? See, actually, this is one example, right? So in case of 10 nodes, let's say you have 5 containers, 5 replicas. Okay. Let's say one of the node is down, like one of the node is crashed. The kernel crashed. It is, you have to switch it off. Now what happens is there are 4 replicas, but as per the deployment requirements, we want 5, right? In another node, it will immediately create another pod to make the replica count as 5. Got it? We have 5 nodes. One pod is running. The node is down. So the Kubernetes cluster will ensure that the pod is created in another existing node so that the replica count is same, 5. Any question here?
Oh, got it.
Again, yeah, all these things are taken care internally, right? We don't have to really do anything. All these things, make Kubernetes very robust platform for this. They have a lot of, the consensus algorithm. Also, every time when you go and say something, right, first the user request will be taken. The state will be stored in the HCD. Like I want 5 replica means it will tell that let's make the deployment 5. And then it will start go and do all the changes under the hood and then report back to the user. If it is not able to create, it will immediately tell, it will create the state, but it will be keep trying it. So, so the first, whatever the user request is asked, it will be stored. It will not create and then store. It will first store, then only it will go and create. So this is one small difference from other software systems. Yeah, so I think we'll go to the next one. So I just deleted it. I think I have shown you how. See, also we can actually create it. So in with YAML file, I just shown one example, right? We can actually, create it directly as well. I'll just show you that example as well. So you can see it here, right? Kubectl create deployment, my deploy, specific image, these many replicas. You see, I don't want to create means you can say this -dry run equal to client means you actually don't create it. I'm trying to create the YAML file only. Got it? So see, I have not created anything now. So nothing changed. You see here from command line, I just say that I want this specific image, this many number of replicas, and then I could create a YAML file out of it. Can we actually try creating it automatically? Let's give it a good name. My deploy test. Okay. Let's not do a dry run. Instead, we will just create it. You guys are getting what I'm trying to do here, right? Kubectl create deploy. Are you able to see?
Yeah.
Yeah, Kubectl create deployment, my deploy test. I'm just showing an image and then replicas. Okay. So we created a deployment. Let's see. So I created a deployment. Yes, having 5 are ready. Good. So Kubectl get pods. So you see here, my deploy test, 5 pods are running, right? So that's mostly it. There is something called service, right? So we want to expose whatever server is running by means of IP address and port. We make use of the service. So let's see how to create the service. I just created a service like this, right? So kubectl apply -f this service. What is there in service? We'll see. The service name is my service. It has given a name. You go and select this label, my app. Again, it is using the protocol TCP. It port is like the 80 port. It will be targeting the 80 port. So this is mainly for the container port. So this is how you go and create the service. There are some 3 different types of services like node port, load balancer, cluster IP. So cluster IP is for internal purpose. Like, so you want some services to be accessed internally. That time you go and tell that I want to create a service of type cluster IP. You want the same service is available in the same node port, like some within the servers you want to communicate, you make use of node port. Now you want to actually expose it to the outside world, you go and tell the type as load balancer. So I will explain it in detail later. So just remember there are 3 different types of services: node port, cluster IP, and load balancer. So today we have seen pod, how to create a pod with a YAML file, and then how to check the logs, how to create a deployment, how to scale it, scale down, how to mention the replicas, what is created whenever we create a deployment, how to debug in general, how to do the logs, describe, how to get a YAML file from the existing deployments, and then the service. Any questions here?
Sure.
Yeah, I have this file created in the Git repo. You guys should actually try it. See, unless you try it by hand, nothing's. I think it will go away, right? So it will go away from your brain. So please try it out. Yeah. So I think mostly I'm done. Any questions? Means please guys. I will.
Yes, Shiva, now could you tell me like what's the difference between this Minikube and kubectl? They are same problem. Yeah.
Yeah. So see, Minikube, you want to do some testing of a simple application in your system. You go and say, as the name says, it is mini Kubernetes, mini, right? So you want to run it in your laptop, right? So you want to run it in a single system. So it is very less resource consumed one. It is mini version of the existing Kubernetes. That is Minikube. Now you want to actually set up some 5 server Kubernetes. You have to actually make use of a tool called Kubectl, Kube Administrator. So you make use of that tool to create a cluster. Okay. What is Kubectl? Kubectl is the client. Whether you use Minikube or you use actual Kubernetes cluster or you make use of AWS based Kubernetes service or Google based Kubernetes service, anything, you have to actually make use of some client, right? As a user, you want to make use of some client to access that cluster, right? There, you just go and download the kubectl command line tool and make use of it.
Yeah, got it.
Yeah. So the Minikube, kubectl, Kube ADM, all are available in the kubernetes.io repo. I will share that link. Yeah.
Okay, Shiva.
So yeah, Kubernetes as a software is driven by the community, open source community. It is actually developed by multiple companies. Almost all the big corporations are making use of Kubernetes. So they all contribute back to the Kubernetes. So they meet once in a while, to decide what kind of features they want. If some company has a specific feature, they will tell that we are thinking about this feature. We want everyone to collaborate to make a design and then to implement. So such kind of open source collaboration takes place. So if you guys are interested, you can get involved there as well. As a DevOps engineer, you will be actually just making use of the tools, right? So sometimes if you want to get involved in the community also, you can actually get involved. Yeah. So anything else?
I think it's
Yeah, time to wrap up.
today. You have explained so much to all of us. Thanks, Aruna, for your time. So, guys, please go back and then clone this particular repository that I pasted in the chat, and you reach out to me for the t3.medium instance, because if you reserve a t3.medium instance, you will be charged. So I'll pass on the access key and secret key to all of you. That you can make use of it, and then you can provision your EC2 instance, and then start cloning this repository in the EC2 instance, and then start your Minikube server over there, and then practice all the commands that Saruna explained you today. Any specific questions on that? Anyone? Sure. So I'll upload the recording today, and you can see that recording and then play. I mean, after reserving an instance, you can play around with it. Sure. Thank you all. Thank you, Sarana.
Thank you. Thank you, everyone.
Yeah.
Thank you. Thank you.
Thank you.
Thank you.